Good morning, everybody. Welcome to Diploma Online class. The subject name is Analog Communication. The unit 4 name is Antenna and Wave Propagation. Session number 7. Now, table of content. Ground wave propagation. Here, I will try to cover what is wave propagation, what is ground wave propagation, where will be used. The second one is sty wave propagation. I will try to cover what is sty wave propagation, what are the applications of sty wave propagation. The next is space wave propagation. Here also I will be explain the space wave propagation. After that I will try to compare all these ground wave, sty wave and space wave propagation. Thereafter multiple choice question reference. Let us start this lecture. See, before going to explain wave propagation, all of you must be understand clearly about communication system. I already explained in the last lecture. Again, I will explain something. Here is transmitting antenna, receiving antenna. We have to send a signal in the radio wave signal. See, what happens here is that the position of transmitting and the receiving antenna must be placed in such a way that the propagating wave will be received correctly by the receiving antenna. If it is not correctly fit the transmitting and receiving antenna, the wave cannot be traveled correctly and cannot be received by the receiving antenna. One more point we have to explain before going to explain the wave propagation, that this diagram. In this case, here is transmitter, receiver, earth. This is the atmosphere. Here is the satellite. From Earth's surface up to 12 kilometers, that can be considered as a troposphere. From 12 to 50 kilometers can be considered as a stratosphere. After that, 50 to 80 kilometers mesosphere. After that, 80 to 720 kilometers ionosphere. See, I already know that the wave propagations are ground wave propagation, sky wave propagation, and space wave propagation. Out of these three, only two, that is ground wave propagation and space wave propagation, used in troposphere layer, but the sky wave propagation only used in the ionosphere. It is very important to keep in mind before going to explain the wave propagation. All of you must be remembered the number of kilometers in which cover for each and every different types of atmosphere. Different types means different layer of atmosphere. I will explain ground wave propagation. See, the travel in contact with Earth atmosphere. You can see in this diagram the transmitting antenna and the receiving antenna. The wave traveling from transmitting to receiving. The direction of wave traveling is same as that of the curvature of the earth. If it is the curvature, if it is the earth is in straight line, the wave propagating from transmitting antenna to receiving antenna becomes straight line. So the travel in contact with earth surface. The next is reflection, refraction and scattering by object on the ground. See, Reflection, refraction, and scattering is made by object. The object may be a hills, then building, then any of the object. When wave propagated toward any of the object, it start diffraction, reflection, and scattering. The next is transmitter and the receiver need not see each other. Means the transmitting antenna as well as receiving antenna should not be opposite to each other. It if can't see the transmitting and receiving antenna but able to propagate the wave from transmitting to receiving. At VHF or IO frequency provide more reliable propagation. Means in order to propagate, in order to transmit the signals from transmitting to receiving antenna, it should be the frequency up to one range, that is higher frequency range. If it is higher frequency range, it is possible to make reliable communication. Reliable means without loss. The propagating the signal attenuate as distance increase. If the increase the distance between transmitting and receiving antenna, then gradually attenuate the signal. We will try to avoid to increase the distance between transmitting and receiving. It should be reduced as much as possible in such a way that the signal cannot be attenuated. The frequency up to 2 megahertz. The transmitting frequency, the maximum up to 2 megahertz. Example, AM radio and submarine communication, that is long wave. These are the common ground wave propagation. You see, from transmitter to receiver, it may be a direct wave or reflected wave. If it is direct wave, the transmitter and receiver, the wave is propagated directly. Suppose in some case, it may be reflected by object. If it is reflected by object, then that can be considered as a reflected wave. In ground wave propagation, it not only direct wave but also reflected wave. Here you can see the same concept in the different image. The signal will be reflected by any one of the objects is given in this diagram. The next is sky wave propagation. In this case, the signal is reflected from ionoid layer of atmosphere back down to Earth. I already explained in the starting, that is ionoid layer. Ionoid layer means from Earth's surface up to 80 to 720 kilometers away from the Earth's surface. The signal is reflected. You can see from Earth's surface up to the distance 80 to 720 kilometer distance, the signals will be reflected back to the Earth. In this case, it's nothing but skywave propagation. The signal can travel the number of back and forth between ionosphere and Earth's surface. You can see here is transmitting antenna, here is receiving antenna. Not only signal is transmitted only one time, many reflection can be take place. Therefore, in case of skywave propagation, it not only single reflection take place, it is number of reflection. In order to make a number of reflection, it requires number of ops and number of back. If it is More number of options back, then more number of reflection take place, and signal get delay to the receiving antenna. By repeating reflection, communication can establish over 1,000 miles of. By repeating the reflection, you can cover the long distance up to 1,000 miles. The mainly at frequency below 30 MHz. The frequency up to 30 MHz you can operate in this skywave propagation. Example: amateur radio international broadcast. These two examples are widely used in this skywave propagation. You can see in another image the transmitter receiver. Here is ionosphere. The signal is sent over the ionosphere, then reflected back automatically by the atmosphere, then sent back to the receiver. The ionosphere range is 80 to 720 kilometers. Here in this image, the signal received over wide area regardless of the terrain. There is a multiple reflection take place in order to cover the long distance. The next is space wave propagation. In case of space wave propagation, the transmitting and receiving antenna must be within line of sight. The line of sight is nothing but you can see the transmitting antenna and the receiving antenna. The two antenna must be in the straight line. It should be the line of sight. Means the transmitting antenna must be appear the receiving antenna correctly. The satellite communication signal above 30 MHz not reflected by ionosphere. Signal should not be reflected, but signal should be received by the satellite communication. Then the satellite communication will send back the signal to the receiving antenna. The ground communication, the antenna beating effective line of sight due to refraction. Refraction, bending of microwave by the atmosphere. We know that this is transmitting, receiving. We are sending the signal from transmitting antenna to the receiving antenna. The radio signal or electromagnetic wave is refracted or bent, that is due to atmosphere. The velocity of the electromagnetic wave is the function of the density of the medium. Means the bending is happen that is due to the functions of density of medium. When wave change, the medium speed also be change. If the change the medium, if you change the medium, speed also be change. It is widely used in the mobile phone system, satellite system, cordless phone. It also called as line of sine wave propagation. The line of sine equation. The optical line of sine D is equal to 3.57 into square root of h. The effective or radio line of sine D is equal to 3.57 into square root of kh. You can understand the equation easily by looking this image. Here is transmitting antenna, here is the receiving antenna. The height of the transmitting antenna is ht, the height of the receiving antenna is hr. The distance between transmitting antenna and the receiving antenna is a d. From year to year, it can be represented d r, and from year to year become d r also. The d is nothing but distance between antenna and horizon. S is the antenna height, k is the adjustment factor. It is used to find out the distance between transmitting and receiving antenna. The maximum distance between two antenna is given here. In this case, you can easily find out the maximum distance in which the wave propagating from transmitter to receiver. The expression is 3.57 into square root of kh1 plus square root of kh2, where h1 is the antenna of antenna 1, h2 is height of antenna 2. The next I will try to cover comparison between different mode of propagation. Here ground wave propagation, sky wave propagation and space wave propagation. The parameters are frequency usage, propagating wave, height of antenna, distance, signal attenuation. Example. The frequency usage. The ground wave propagation less than 2 MHz of frequency used by ground wave. In this case, the 3 to 30 MHz, but in space wave propagation more than 30 MHz. And the propagating wave. The wave propagating from transmitting to receiving antenna in the ground wave propagation is radio wave propagate along surface of the earth. The wave is propagate along the surface of the earth. In sky wave, the radio wave get diffracted from the ionized region. But in space wave, directly propagate from transmitting antenna to receiving antenna without reflection. Reflection can be happened in sky wave, but reflection cannot be happened in space wave. But here it possible to both direct wave and the reflected wave. The height of the antenna in ground wave propagation very high, sky wave high, the space wave is low. The distance coverage, the ground wave short distance coverage in sky wave propagation 60 to 300 km coverage, and in space wave propagation very long distance cover. For the long distance communication we use the space wave propagation. The signal attenuation. Signal attenuation means signal reduced. The voltage or current level will be reduced. More as increase the frequency and distance. If you increase the frequency as well as distance, the signal attenuation will be more. In the sky wave propagation, more than space wave but less than the ground wave propagation. The space wave propagation less. Compared to these two wave propagation, the space wave propagation has the less signal attenuation. The example is AM radio, military communication, here is TV transmission, satellite communication, mobile communication, and also optical communication. These are the comparison. It is very important. You must keep in mind in such a way that you will understand clearly what are the comparisons between these mode of propagation. Next is multiple choice. The sky wave propagation range between the frequency from 2 megahertz, 2 megahertz to 30 megahertz, 2 gigahertz to 30 gigahertz, 30 gigahertz to 50 gigahertz. The sky wave propagation, it is range from 2 megahertz to 30 megahertz. Option B is the correct answer. High frequency long distance propagation mostly depends on high frequency long distance propagation mostly depends on ionospheric reflection, tropospheric reflection, ground reflection, inverted reflection. High frequency long distance propagation. What is the answer? Option A means ionospheric reflection means we are using the high frequency by the sky wave propagation. It also covers the long distance. Next, communication through line of sight can be increased by decreasing the height of the antenna. True or false? Communication through line of sight. If you want to communicate through line of sight, can be increased by decreasing the height of the antenna. If you decrease the antenna, it's difficult to make a line of sight. If you increase the antenna, it is possible to easy the line of sight. Means we must increase but not decrease. Here is given decreasing. Decreasing means it should be a false. You see, explanation is given. The line of sight provides direct communication link from transmitter to receiver. If the height of the antenna is increased, then line of sight is also be improved. If the height of the antenna is decreased, the line of sight not to be improved. Therefore, the option B is the correct answer. The next is space wave propagate at which frequency band? VHF, HF, MF, EHF. Space wave means from 30 megahertz to several megahertz. It is come under which range? VHF. Option A is the correct answer. Thank you.